Hello YouTube, RJ. Hey, today got a couple parcels in we're going to open up and take a look at what I got. We're going to talk about a few trials and tribulations with getting the Link Easy shortwave receiver kit together and kind of give you an update there. And we're going to talk about some fake J310 JFETs that I ordered from AliExpress that turned out to be lasered off and fake. They're not even JFETs. And what I've decided to do about it. And so hang in there. We'll get to all of it before we're done. It won't be a real long video today. So let's go ahead and open up this and see what we got. Okay. So what we have in here is, I bought that 50 amp hour lithium iron phosphate battery to be like a power source for radios and stuff for me, and I needed a way to regulate power, and I've got some USB-C stuff that I want to be able to charge off of that battery with. And so I saw these and I decided to pick up, there was a 3-pack, I decided to pick them up. They weren't too expensive. And what they are is, if you remember the video a while back where I had some little PD decoys, we called them. They were USB devices that communicated with USB-C PD power supplies, chargers, and told them that, hey, I want 5 volts, I want 15 volts, I want 20 volts. And you remember we played and tested some of those. This is the opposite end of that. This you apply power to and it becomes the controller on the other end so that it will give you what you ask for. And so this thing takes in DC 8 through 30 volts and it outputs up to 65 watts. Any of the PD voltages up to what you supply it. In my case, it's going to be about 14 volts, which would be a 12 volt. And so my idea is to take 2 of these and I'm going to build this into a little board, maybe a little box, whatever. I'm going to put 2 of these in there, and I'm also going to have a circuit board with a couple regulators, and I'm going to build a little power octopus, if you will, that will like double stick down to the top of the battery, be connected to the terminals through a fuse. And then what it's going to do is going to give me 2 USB-C PDs up to 12 volts. It's going to have a couple 9-volt feeds. These are on the back of this. It gives you 5 volts. So you can get 5 volts out of here. You can get PD up to, in my case, 12 volts, like I said. And so I'll have PD power up to 12, 5 volts, a couple 9 volts. Then I'm going to have a couple of 12 volt barrel connector cords coming off for 12 volt DC. And this is going to give me a little battery bank setup that I can run all the test radios for the shootout, for the shortwave radio shootout, off the same battery. It'll give me the ability to charge things in the field. I mean, you can plug your cell phone in and charge this. So it'll be a handy little thing. So I'm going to build that. That's what these are for. I've got 3 of them. I'm going to use 2 of them, put 1 of them aside. So that's what this is all about. Later in the video, near the end of the video, we'll go ahead. I'll solder a couple wires on this one. We'll hook it up and just try it out. See if it seems to. One of the things we're going to test is I want to see if my HS100 soldering iron will run off of this. I think it wants 20 volts typically, but I want to see if it'll run 65 watts at 12 volts and still heat up and do its thing. So we'll try that. I'll be a little experiment. We'll try a little bit later on. So what's in the box, RJ? Well, this is something that I saw a long time ago and thought, well, I'd like to have one of those. And I just never got around to it. They're not super cheap, in my opinion. A little pricey for what they are. Seem like nice devices. Only have a couple gripes with it. And since I don't know if you saw the last video where I got into our Let's Talk About Transistor series, where we're going to walk through transistors and kind of do an educational series all about transistors. I thought this would be very handy for that, so I picked it up. And what it is a Peak Atlas DCA Pro 75 semiconductor tester. It's kind of their high-end unit that allows you to test semiconductor devices. It connects to your computer via USB and allows you to not only do normal tests like, my little cheapy device you see me use all the time to check transistors. It goes way beyond that. It gives you a whole lot more information about them. Allows you to do charts on your computer. You plug it into USB. It gives you charts for transistor curves, gives you all of the specs of the transistor. So this is going to be a very helpful thing during our transition trainings, because I'll be able to bring up, and I mean, you get an idea here they're testing a MOSFET, and it shows you the kind of information that you can get from a MOSFET. Look at all the values. You can basically hook it up, get this information, and then what you really can do, what this really will help with, is fakes, like them J310s. Hook them up, get all the information, pull the data sheet up, and you immediately be able to tell, is this really a J310? Is it meeting the specs? Also, of course, maybe it's bad. You're testing a transistor and you want to know if it's good. Maybe it's somewhat working. It tests, the old diode test seems okay, but it doesn't seem to operate in the device right. You hook it up to this, you look at the specs, you look at the data sheet, and you say, hey, this thing is not doing, what it should be doing, and therefore we need to replace it. So they call it an advanced semiconductor component analysis with USB and graphics. So anyway, very interested to kind of give a run through on that. Now, I'm not going to do testing today on this. You'll see that in the upcoming talking about transistors. We'll use it quite a bit as we go through that series, and you'll get to see it in practice. I can't really give you comments much other than what I see watching other YouTubers, reading the specs. The only negative I have is the voltage and the current that it can supply for testing things. Really good for small transistors, not going to be so good for power transistors. It'd be nice if it had a little more oomph in the current and voltage. For example, you can't test any voltage regulator over 8 volts. This thing has a battery that steps up to 12 volts, so the closest it can get is 8 volts for testing voltage regulators. So it'd be nice if it had a little higher voltage drive, a little higher current. We could test bigger transistors, bigger voltage regulators, bigger Zeners. Not going to be able to do a Zener over about 8. That's that about this. Let me put this away. I'll go ahead and tell you a little about some of the issues. I'm going to cut over some little video clips I cut before working on the Lynx Easy Shortwave, that you see some of the little issues I've run into as time went on. And then we'll end up with testing out this little USB-C PD distributor. So I want to show you the tolls and tribulations of trying to get the little Lynx Easy Shortwave receiver kits done. Got the parts in, I've sorted out the kit, lots of parts, and now I'm ready to start programming calibration for the SI5351 and the ESP32s together, so I can pack them up, seal them up, and put them in the kits. That way the module you get has the code on it with the EEPROM program with a calibration for your SI5351, so they match and your frequencies on it. My plan has been all along to take an extra board and go ahead and just put sockets on instead of mounting the modules, and then go ahead and put me a small piece of coax to run to the frequency counter. And then what I do is I'll plug in your ESP32 and your SI5351. Now, it does mean I have to solder the little header on for you, but that's okay. One less thing you have to deal with. And then what I would do is flash my code to the ESP32 that does the calibration, run it, calibrate, and then I flash the code for the radio onto it for you, pop them off, bag them up, send them on their way. Well, I start to do this, and I want to make sure the sockets are directly straight up and down, perpendicular, so that the stuff will plug in easy. So I go and I pull a brand new ESP32 from one of the kits, and it's SI5351, and I go to plug the ESP32 in so that I can line the sockets up, and I run into a little bit of a problem. Let me see if I can make sure you can see this well. This ESP32 is a little narrower than the sockets. And I'm thinking, what the heck? I knew there was different ESP32s, but I made sure to order the exact same model. And so I went back and I said, well, I've got one of the original ones from my original order when I was building the kit. So I went and pulled it. Here it is. And surprise, surprise, that thing drops in perfect. So what I've run into is the person that I ordered these from originally, he was out, but I went and looked the same model up. It's a W Room 3D ESP32 Dev Kit C. Okay. Well, it turns out that they changed the Dev D kit, and people were griping, and it is true. You do have to your breadboards. You can't just plop these in the breadboards. They overlap too far, so you don't have any pins on a breadboard. You can't fit these on a breadboard. You have to like take a header out, put two of them together. And if you remember, on my breadboard, I did that. I took two breadboards, took one side out, put them together, and made it to where I could plug these in. Well, they decided that they would miniaturize them down a little narrower, just a little narrower to where you didn't have that. So they've come out with a new version, version 4, and version 4 is just 1/10 of an inch narrower. So it won't fit any of my boards or anything. So I've got a bunch of these and they don't fit the boards. What do? I've got all these boards. I could have redesign the board and have a whole bunch of new boards sent, spend the money to do that. Or so basically what I've done is I went ahead and I found someone who had the earlier versions and I've ordered enough to do the kits, and I've just got a whole bunch of these little ESP32s. Maybe I'll change the board, keep them, change the board, and hope that we sell enough kits that I need to do another bunch of kits, and when I order boards for them, I'll move this socket in just a little bit, and then I have to build another one of these boards to program with. But so this is what you go through. The kit business is not for profit, and I'm not doing these for profit. The guys at Solder Smoke always make a joke. They always say, you could make dozens of dollars at that. And it's absolutely true. I doubt I'll ever make even dozens of dollars. But if I can get these kits out and you guys enjoy them and they bring happiness to you and gets people interested in electronics, it's worth it to me. And if we sell enough of them, I'll figure a way out to get another bunch made up and to go out, as long as the U.S.-China trade tariff war doesn't get me, which it may well do. So anyway, just a little update. Just wanted to show you, when you're wondering why it's taken so long for RJ just to get this kit out, this is the kind of things I've been dealing with. This is not the only one. This is just some of the things. You probably noticed the graphics on the board. You notice it's not the same board. I'm on the 3rd board to get everything just the way it is. The last board was perfect. That was the one I built the radio on, except I had to run jumper wires to the little LM386 amp, because I kind of decided to do that a little later in the path. Well, there was nowhere to plug it in to get power on the board, so I had to go under and jumper wires to power it. So I had added a set of pins here to pick up power. So that meant a 3rd design of the board. So this is the 3rd and final design. You have the little pins here where you can plug your wires in to get power for your LM386 audio amp for the speaker. And the 4th board may be this socket's a little narrower for these newer ESP32s. Good news is, if enough of you buy these kits and I run out and I have to do more kits and I can get parts from China without paying 200% tariffs, I won't have to order ESP32s. I have plenty of them for the next batch of kits. Okay, it's a couple days later and I've got the W30 or ESP32 modules in, the supposedly correct ones. And so now you can actually see, here's the version we've been using, and here's what I had ordered where I got a newer version. I'm sorry, I'm backwards. This is the version I got in, the newer version. This is the version that I used when I designed the board for the Easy Receiver, and you can see that there is a 1/10 of an inch difference in the width of the socket. It's just a very little difference, you can see. And of course that caused a lot of issues for me, because of course this wouldn't plug in. This will plug into the board. So anyway, this is my little jig for calibrating the ESP32s to the SI5351s for the kits. You can see one of the little 51 or 5351 modules here. And so all I have to do is plug them in, plug the ESP32 in, hook up the hook USB up, hook this board up, then I plug in the USB to the unit. I got to turn the right way. I didn't. That powers everything up. It connects to my computer, and then I just flash this thing with the calibration software, calibrate it as I demoed in an earlier video. Once I calibrate it, and it writes the EEPROM data for the calibration into the ESP32, then I just flash the ESP32 with the actual Easy Receiver firmware and pop it out, put these together, stick them onto the foam, put them in the static bag in the kit, and you guys get a calibrated pair ready to be used in the kit. So just a little explanation of how the process works. So we do have the right ones now to do the kits. And I'll get all these flashed today and put in the kit, sealed up, and kit's pretty close to being totally together. I've got to finish a little bit of instructions and we'll be ready. Then it's just a matter of doing the shootout video for the receiver. So we're making headway. It's you know, one little issue after the next, but we're getting there. So don't give up. It's coming. Okay, I got the bench cleaned off. I took my jumper cable clips that I used in the previous video working with this battery, and I just soldered them on. You can see they're just soldered on the plus and minus here. And I've got the switch over here off, and we'll kick it on in just a minute. And so my test is going to be to hook up the HS01 soldering iron and see if we can get this thing to work. It takes PD power. It's got a 65 watt, you know, plug in the wall wart power supply. And I think I checked it one time and it was like 20 volts output. So I'm curious if it'll run off this 14 volt battery through this. So we're gonna give it a try here. So go ahead and plug it in and we'll turn the power on and we'll see what happens. It powered up. It definitely powered up. Got an LED here, got powered up here. Let me tell it to warm up and start pulling some current, see what happens. It's warming right up, appears to be working just fine. So this may be once I get this little box made up for this thing, I'll have a portable soldering iron set up. I can carry this out anywhere I want to go and solder with this. So that's really handy sometimes. Sometimes I have to work on my antennas out, set my wire antennas down and do work every year or so. And I need to solder something. And man, it's a pain to pull extension cords out and everything. This would be nice if this would work for me. So let's see if we can melt some solder here. Yeah. I don't know how much. I don't know how, you know, if it's as powerful as it is with, yeah, it's telling me it's running on 12 volts. So it wants me to know it's not running on 20 volts. It says, if you can read it right here, probably not. It says power bolt, lightning bolt, 12 volt, set 360. So, I mean, it's melting solder. It's melting solder just fine. Doesn't seem to be a big deal. So the board definitely works. So it'd be nice to have that capability. So that's what I'm going to do. I'm going to build up a little setup. You'll see. I'll demo it when I get it done, using a couple of these and a couple of voltage regulators and a few heat sinks, and we'll have a little power adapter that screws on the bolts here and gives you multiple DC voltages out. So that'll be kind of cool. Hey, thanks for tuning in. I know this wasn't a real long video. I just been very busy with things, and this is just wanted to show a few things. Hope you enjoyed it. If it wasn't educational, at least entertaining. And most of all, hope to see you in the next video.